equations. This was the preparation for what we need right now. So this is 4.4 exponential plus log equations. We're going to start with exponential. And we're going to start with simple examples. So let me open the text. I'll choose, then you choose, and so on and so forth. We're a team. So this is page 516. So I'm going to start. We're going to start from here, from 1 through 22 first, and then the rest. So I'm going to start with something very simple, like number 3. So this is 5 to the x equals 125. Why I consider this easy is because it's not difficult to see that 125 is 5 to the third. So obviously the whole equation changes into 5 to x equals 5 to the third. What do you think x could be? And there is only one correct answer. What can it be?
3.
Only 3. Excellent. So if two exponential notations having the same base are equal, again, two exponential notations with the same base, if they are equal, their exponents have to equal. So as long as I can present both sides with the same base, here I cannot. So there's a different technique for this one. I can never present 3 and 7 with the same base. There is no such thing. But as long as I can present both sides with the same base, that's easy. Okay, so let's continue still from 1 through 22 before we move on to the next step. So let's choose now anything you want from 1 through 22. Anything.
We do 7.
Yes. Here's 7. In 7 we have 4 to 2x minus 1 and equals 64. I have several options. I'm always I'm going to try to see if I can have the same base. Yes. If I remember that 64 is 4 to the third, I'm in business. So then I have 4 to 2x minus 1 equals 4 to the third. What has to happen? I have two exponential notations. They have the same base and they are equal. What has to happen for this to equal this? What do you think? Anyone, please.
X has to equal 2.
Yes. X has to equal 2. In other words, 2x minus 1 has to equal 3. I set them equal to each other. I move 1 to the other side. I divide 2, and this is it. X has to be 2. Great job. Good. Anything else? Let's continue choosing. I will choose 15. And 15 we have 6 raised to x minus 3 over 4 equals the square root of 6. Can I present both sides with the same base? There is nothing I can do to the left-hand side. But the right-hand side is 6 to which power? Raised to what? Anyone? The square root of 6, we said, is the same with 6 to which power?
1/2.
Very good, awesome. Two exponential notations have the same base and they're equal to each other. What has to happen? Otherwise, they cannot equal each other. What should I write? That x minus 3 over 4 must equal 1/2. There's no other way. This is a proportion. I will cross multiply. 2x minus 6 equals 4. 2x equals 10. X equals 5. Is this okay? Do we understand the steps in 15?
Yes.
Perfect. Let's see if we need anything else from this set. Look carefully and say, I want this one or that one. Anything else catches your eye?
Can we do 23?
Yes. Before we do 23, do we need anything else from 1 to 22? And then we'll start with 23, I promise. Do we want anything else from 1 through 22?
Can we do 20?
Yes. And I think we should do 20 and 22. Yes, let's start with 20. In 20, we have 8 to 1 minus x equals 4 to x plus 2. Good. Can I present both with the same base? Yes, I can, because I know that this is 2 to the third, and I know that this is 2 squared. So, 2 to the third, everything to 1 minus x equals 2 squared, everything to x plus 2. Now we have to remember what happens to these powers. So I copy the base. What do I do here? I copy the base. What do I do here? Which operation do I apply?
Will it be multiplying?
Thank you so much. 3 minus 3x to x plus 4. Excellent. Of course. Copy the base, multiply the exponents. And I have to distribute. 3 to 1, 3 to negative x. 2 to x, 2 to 2. Very good. And now from here, this is easy. What do I have to write and solve? What is the equation that I have to write at this point and solve? What do you think, please? Two exponential notations with the same base are equal to each other. What has to happen?
Is it 3 minus 3x equals 2x plus 4?
The exponents have to be the same, indeed. I move 2x to this side. I move 3 to this side. X equals negative 1/5. And you can say, show me. Show me that this is true. Okay. So, show that this is true. How do I do that? So the left-hand side is 8 to the power of 1 minus 1 minus, so it's plus now because it's minus minus. 1 over 5 is 0.2. Okay, And now 4 on the other side raised to negative 0.2 and plus 2. When I hit enter, if I don't get the exact same answer, my negative 1/5 makes no sense. Okay, so let me just make sure that I entered everything correctly. Yes, negative 0.2 plus 2. So if I don't get the same answer, negative 1/5 means nothing. Good. Let's also do 22 and then we'll continue with 23. Any questions on 20? Okay. Oops, sorry. Okay, I have to